In mid-1944, Nazi Germany was in ruins. The 8th Air Force, flying high-altitude daylight missions from bases in England, was decimating German cities, factories, industry, and more important to the Rhineland defenses, Luftwaffe air bases, aircraft, and runways. This made painfully clear several problems to the German high command. One problem was that they had seriously misjudged the need for an evolving Luftwaffe force that could be used to defend the German homeland. In their arrogance and overconfidence, they relied too heavily on the Stuka and other old aircraft designs that were initially introduced in the mid-1930s. And they refused, until it was too late, to produce a fighter that could achieve an attack at the high altitudes of the Allied bombers. The one glimmer of hope that they had was the newly designed Me-262 jet-powered fighter. It was fast and lethal, but Hitler decided to misuse its potential as a fighter-bomber against Allied ground forces. Another problem was that the aircraft that they did have needed well-maintained and lengthy runways, both of which were in very short supply by mid-1944. So what was the German military to do against the Allied bomber onslaught? What kind of weapon made sense when you needed to hide its existence easily, have minimal facilities, and ease of movement about the German homeland? They focused on the VTOL, or vertical takeoff and landing design. But where and when did this interest in such a cutting-edge aeronautical design originate? It actually began in 1933. When Adolf Hitler began to build his Luftwaffe against the Treaty of Versailles, he tapped German World War I hero and fighter ace Ernst Udet to begin preparations and planning for a modern air power. Udet had spent the years since the end of World War I pursuing his love of flying. A lot of his pursuits had kept him in the United States, flying in Hollywood movies, racing, and participating in air shows. With the knowledge of American culture, industry, and ingenuity that he had gained from his time in the United States, Udet pursued Werner von Braun for a design for a vertical takeoff and landing machine for defensive purposes of the German homeland. Von Braun returned a VTOL design, the Interceptor, which hung vertically on rails in a hangar-type structure from which it could be launched. Or, to be mobile, it could be launched from 2 mobile truck-mounted towers in the field. Unfortunately for the German war effort, the arrogance of those in power did not allow for the possibility of having to defend the German homeland, so the project was rejected. Then, in 1941, with the failure of the Luftwaffe in the battle for Britain becoming ever more evident, Udet committed suicide. The idea of a viable German VTOL program died with him. Then, beginning in early 1943, Udet's prophecy became a reality. The German homeland came under attack and its defenses were desperate. A request was made for the submission of designs for either a VTOL aircraft or a zero-length launch aircraft to allow a proper defense against the Allied bombing. There were many submissions both prior to and after early 1943. The Natter by Bockum, which used an improvised tower launching system. The Interceptor, in its many versions by Werner von Braun, initially offered to Udet in 1933. Otto Muck submitted a design of which little is known at this time, but was the first to incorporate a dual-propeller system at the nose of the aircraft. Heinkel had its tail-sitting VTOL called the Lerche, which was a piston-driven assault plane. They also had the Vespa, very similar to the Lerche, but it was driven with a centrally located turboprop and was to be used as an interceptor fighter. There were a couple of designs that were not traditional VTOLs in that they used vertical takeoff to get airborne, but used horizontal methods to land. Fiesler had its FI-166, which was a VTO, vertical takeoff, but was a horizontal landing machine with a skid landing gear system. The Heikel P-1077 was another version of a vertical takeoff machine with a skid landing system. Another skid landing aircraft was the odd-looking Junkers Flugzeugbau, which would achieve flight either from a trolley system or a vertical launch system. Focke-Wulf had a couple of designs, one VTOL design that was called a flat riser, that was powered by dual counter-rotating propellers in a turbojet and gearbox assembly, or in today's terminology, a turboshaft. But the one Focke-Wulf design that was singled out for development was the design which came to be known as the Triebflugeljäger, or the Triebflugel. The Focke-Wulf Triebflugel design had its origins from the early 1930s scientific studies of zoologist Erich von Holst, a professor at the Göttingen Technical University. He was inspired by the strong and agile flight of the common dragonfly with its ability to fly vertically, horizontally, backward, side to side, and to hover. It was von Holst's belief that these same properties could be designed into a man-flying machine. Von Holst actually had two separate working stick and paper models of flying machines that mimicked the flight of the dragonfly. Now, while the Triebflugel never flew, its design and basic concept struck a raw nerve with the two opposing sides after World War II ended and the Cold War began. The U.S. and British bomber missions against Nazi Germany set a new precedence for the waging of war. Swift and total air superiority was Mission 1. To achieve such a quick and decisive air superiority over an enemy meant that air forces, runways, and facilities had to be on the top of every target list. The U.S., England, and France began their own VTOL programs from captured German documentation and research. The hope was that these programs could ensure that they would have viable defenses in the case of a Soviet first strike that was sure to knock out most, if not all, military air facilities. The first was the Pogo, designed and manufactured by Convair. This particular design was a tail-sitting version similar to the Triebflugel, but with the pilot now sitting in a cockpit that was centrally located on the fuselage. The Convair design moved the dual counter-rotating propeller assembly to the nose of the aircraft rather than having it amidships as in the German Triebflugel. There was an advanced Pogo pod design which moved the cockpit to a pod on one of the base fins to give the pilot a better view and to allow for armaments on the opposite fin. Then Lockheed, of today's Lockheed Martin, started development of the XFV-1. Again, a tail-sitter similar in design to the Triebflugel, but with a cockpit positioned just forward of an added single fixed wing. The dual counter-rotating propeller assembly, similar to the Convair Pogo, is positioned at the nose of the aircraft. Ryan had a version similar to the Pogo and XFV-1 called the Vertijet, but used a tower and hook system for launch and landing. So it was not really a tail-sitting machine, it actually hung on a launching tower. The U.S. was not the only NATO country to see the potential of such an aircraft design, nor were they the only country to see the threat of expanding communist influence and the threat of a strategic Soviet first strike. England, with its Supermarine 440, tried to capitalize on the technology and incorporated a fixed wing for added stability and the mounting of weaponry outside the radius of the dual counter-rotating propellers. The French had a series of designs ranging from the Coléoptère to the C-450, which actually flew, but very nearly killed the pilot when it crashed in testing. The Canadians had the Avrocar, a flat riser that resembled the Focke-Wulf design that was originally conceived in 1944. On the other side of the Iron Curtain, though little is known about it, the Russians had their own VTOL project named Juryev Kit-1 and Juryev-2. It was initially designed in 1946, but never left the drawing board. While these multiple projects were developed, tested, and refined for nearly a decade, they never were perfected. The major flaw being that the pilot, up on landing, could never have a clear view of the ground or the horizon. Most of these VTOL projects were on the drawing boards by the late 1940s and in test flights by the late 1950s. However, by 1960, a single act by Soviet Russia would render them all obsolete. In May 1960, U.S. Airman Francis Gary Powers and his U-2 spy plane were shot down over Soviet Russia with a single surface-to-air missile, or SAM. With the perfection of the SAM defense system by the Soviets, it would become the mainstay of air defenses around the world, even for today's modern armies. But what of the years of design and millions of dollars of research that had been invested in the VTOL programs from Nazi Germany to the NATO countries? Honestly, little is known about it after the mid-1950s. After the Canadians decided to abandon their Avrocar project and the U.S. military took it over, little to no information is available. It is believed that the U.S. military had a very significant technological breakthrough that led to cutting-edge air machines. This, in turn, led to all information being classified and thus unavailable. Much of this possible breakthrough is believed to have been as a result of captured German plans of disc-shaped aircraft. It is also suggested that the whole Canadian-U.S. collaboration was simply an expensive ploy to cover up the tests of captured alien technologies. Conspiracy theories are abundant. Whether a huge technological breakthrough was achieved, it was a cover-up of alien technology testing, or the whole concept was simply abandoned and scrapped, one thing is certain. Any information that may have followed went black or was classified top secret indefinitely. So with the antiquation, scrapping, or the hiding of the various VTOL programs around the world, what became of the years of in-depth study of insect flight? The spirit and work of Erich von Holst lives on today in current studies primarily funded by the U.S. military. The studies, again attempting to apply the physics of insect flight to mechanized flight, are developing what are to be known as MRIs, or mechanized robotic insects. These MRIs could have many civilian and law enforcement applications. However, the immediate use is being focused on the war on terror and other military uses. The MRI could overfly the battlefield or fly into dangerous or inaccessible locations. It could then locate and identify targets, transmit coordinates to command facilities, and be there for the elimination of the marked target, thus bringing the vision and dream of Professor Erich von Holst into reality.